Hi everybody. Now in today's video what we're going to do is we're going to come down to the bottom of our OneNote and we're going to be doing an activity called the sine curve fitting. So the idea is I'm going to give you a curve and get you to come up with the equation of that in terms of a sine curve. So if you open the document up, it will bring you to this page here, and this we're going to do a couple of examples and you can do the rest of them after that. So we need to work out what our A, our B, our C and our D values are for our sine curve. Right? And then once we've got that, we can write our sine curve out. So here you've got a couple of things that you need to write up. The first one is, what is the maximum value of my sine curve gets to? Well, if you're looking here, the maximum it gets to is in fact 6. So we're going to write 6 there. The minimum value gets to is 2. And the period of my wave, well, the period of my wave is a time from a position of the wave to the same position. All right, so I could say, well, that there is a position of the wave, all right, and that's the same position of the wave, or that's a position of the wave, and I'm going to that position where it repeats. Actually, no, it's not repeating itself, is it? All right, so it needs to do a complete repeat itself. Right, so I need to do one complete full wave, don't I? And then it goes to this position here to that position there is a good example. All right, so that position there is like 3.0. This position here is like 6.1. Sorry, that's 6.1. So therefore, the period of the wave is like 3.1. Does that make sense? So you can use any part of the wave. It's just so it gets to the view of the wave looking the same. So here what we're going to do, we're going to do each part of the wave in terms of finding our A, B, and these little techniques is going to help you. So the A value is the height of the wave, the amplitude of the wave, and it's going to be our max. Take our min, and we're going to divide that by 2. So it's going to give us a value of 2. All right, our period of the wave is going to be 2 pi divided by 3.1. Now, if I go to my calculator and I do that, so 2 pi, so that's 2 times by 3.14, divide that by 3.1, and that's going to give me an answer like 2. All right, so I'm going to use 2, but you could actually write it in as 2 pi over 3.1 if you wanted to. All right. Our C value, I'm going to insert a line. This is the thing that I need to better do. Our C value is in fact halfway, and I'm preempting the next part, but our C value is symmetrical around that line there. All right, so if I just make that line a bit fatter, you'll see that line. So what I should probably do is do my D value next. Okay, so to work out my D value, that's going to be simply going to be, I've lost my pen now. How would I do that? Right, so that's going to be 6 plus 2 all over 2. So therefore that's 8, it's going to be 4. And notice I've drawn that line at the height of 4. All right, so that's what I've done there. The interesting thing here for that, what I'm looking for is when I'm comparing this to the normal sine curve, if we go back to our Desmos, always starts at 0 and goes upwards like that. Excuse me. So it always goes up from 0 upwards. All right, so that's the key thing there. So what we have to do is we have to go to the part on our curve where it starts going upwards. And so if we can circle that point there, going across, it starts going upwards there. So what's happened is it's been moved this way, 3.0. That makes sense? So therefore my C value is simply 3. And I'm suggesting what you always want to do is you always want to go to the right hand side when you're writing these curves. If I go to the left hand side, I can do that, but then it'll be a plus, but this will always be a take. So now I have to write my equation. So if I'm writing y is equal to, or h of t is equal to, so my A value is 2, sine. Now my b value is 2, so it's 2 bracket t take 3 plus 4. Done. And that's, if I graph that on my Desmos, we'll see what happens. So we've got 2 sine 2 x take 3 plus 4. And I haven't obviously zoomed in like this particular curve, but you can see it's cutting there, it's going up at 3, it's got a height of 2, it's symmetrical around 4, and it's got a shorter period. Alright, so that's the same curve as what we've got in our curve here. Alright, let's do another one that's a little bit trickier. So this one here, let's do this one here, because this one here you don't see a complete wave. Alright, so if I was looking at my scale here, I have to do the same things I've done before. The maximum value that goes up to, that's like 15, 16, 17, 18. So my maximum value is 18. My min value is like 2. And my period of my wave. Now, I'm not seeing complete wave here. So what I want to do is go to this position here, which is going to be like -2. And it's going to this position up here, which is my max position, which is like 14. So if I do the difference between those 2 points there, that's 16. Now that's only a half a wave. So my period of my wave is 32, is what I'm looking at there. All right, so my A value is simply going to be 18 take 2 all over 2. Well, that's going to give me 16 divided by 2 is 8. That's showing my amplitude is 8. My period, that's 2 pi on 32. And I'm going to write this one here as simply pi on 16. Is a nice way of writing that. My C value, I have to do my D value, remember, first. So it's going to be 18 plus 2 on 2, which is going to be 10. So I'm going to get my line, insert a line, and I'm going to draw it around 10. And just make it a bit thicker so you can see it. Right, so where does my curve touch this axis here? Touches that point there, it's going up at that point there. So if I read that value off, that value there is 6. Okay, so now I can write my equation. My equation would be simply y equals 8's my maximum or amplitude, sine of pi on 16. Okay, and then I got my x value. Let's do x this time. X take 6 plus 10. Right, now if I go to my calculator, my Desmos, and I can graph that one there. Now, probably the thing I have to do is I need to work out, because I don't know how to put the pi in my Desmos. So if I work out what that particular thing is, the pi on 16, so it's 3.14 divided by 16. It only has to be approximate, it's like 0.2. All right, so that's what we're looking at there. So if I come to my Desmos and we graph that, and so remember our maximum there was equal to 8. And then my thing is like 0.2. So 0.2. And then my graph here, I had to move that across 6. And then I had to add up 10, I think was my period value. And so if I sort of zoom in on that, you can see it's doing exactly what we were seeing there before. So this is a really simple process for you to be able to match a sine curve to the one that's been produced. Now, we would do this in real life. You know, we might be matching lots of different sine curves to different things. And this makes our life just simple. And that's what life should be about, is making things fairly simple for you. So I would suggest that you make sure you can do this part of the activity.